So that model you can actually represent as a function. And what exactly is happening? You are sending your images as an argument, or you can say like input to your function. And what that model is trying to do is it's giving you some kind of output. For example, if it's a classification task, it's giving you the class label. Okay. So whatever that model is, it doesn't matter. You can represent that as a function. It will always hold. Okay. If you give like an image of tomato, it's going to give you tomato. Okay. So whatever machine learning framework or whatever model you have, doesn't matter whether it's convolutional neural network, it's recurrent neural network, it's just like a very simple machine MLP. You can say that it's a function which takes some input and predicts some output. Okay, so that's a very generalized form. Now, the question is what this function is that defines your model, and we'll come to that later. Okay, so this X could be your image if you're using pixel level values. This could be features if you're trying to use local features. All right, so this is your, let's say, classifier function. That's the output label. Okay, so the training phase is, as we discussed, like in training set, you have a lot of images and you will have labels for those images. So you can describe your training set as this set here, where x1 to xn is like your set of images. All right. And these could be also features if you are using local features. So, and then for each image, you will have some kind of ground truth or some kind of annotation. Okay, so you need this pair. Now what will happen is for each image or each feature, you will pass this as input to the function. It will make some prediction and you will match that prediction to this ground truth. And depending upon how good that match is, then you're going to perform the training. Okay, so that's a high level idea of how the training is being performed. Okay, so the idea is whatever prediction this network makes, like this one y over here, you try to minimize the gap between this prediction and the actual ground truth. Okay, you want them to be very close, or you want them to be exactly same, which never happens, but that's what you want. And you do that for all the samples. And that's essentially your training. Okay, so if you remember like something from your numerical, like mathematics in your high school, this is kind of optimization. Okay, so you're trying to optimize your model based on what is predicting, and you want that prediction to be very close to the ground truth. Okay, so once that process is done, you have optimized your network, or you have optimized your function, then testing is simply you just send like unseen samples to that function and it will just make predictions. Okay, so that's a trained model.